it has got what is called it has got what is called variable coefficient. So we have a1 a naught x power n dny over dx plus a1 x power n minus 1 d of n minus 1 over this other part all the way here. X1 x naught x1 all the way to xn are a constant. So to solve linear ODE with variable coefficient, we make this substitution. Note that a naught a1 all the way to a1 to an are a constant. So we let our x to be equal to exponential t, so that now our natural logarithm of x is equal to t. You call this equation 1. Then we differentiate this one with respect to x. So we are going to have dt over dx is equal to 1 over x, which is equal to 1 over x. So dt over x is equal to 1 over x. You call this 2, which means that if you are given a function of xt, which is equal to y, it follows that dy over dt over dx, we differentiate this by chain rule, will be given by dy over dt multiplied by dt over dx by chain rule. So that is it. So dy over dx will be equal to, in this case, our dt over dx is 1 over x. So we have 1 over x dy dt. So that is what we have. So from it, we can multiply by x both sides, so that we have dy over dt is equal to x dy over dx. Then from here now, we let our dy over dt to be equal to d, and our x dy dt to be equal to dy. So here you can call this equation 3. We call that equation 3. Then the second derivative of y with respect to x, this can be written as d of x into bracket dy of dx. We substitute the value of dy and dx here, which is equal to d. Instead of dy and dx, we write 1 over x dy over dt. There. Then from there now, we differentiate that part, and when we differentiate, we are going to obtain the following. So this one will give you minus 1 over x squared over x squared dy dt. This is a product rule, so I have earned this constant and I have differentiated 1 over x to give us this part here. Then plus 1 over x dy squared over dx dt. So that is what we are going to have. Now, this can be written as negative 1 over x squared dy over dt plus 1 over x multiplied by dt over dt multiplied by d of this squared over dx dt. This is dt, whereby I'm going to separate them, so that now we shall have the following. D squared y over dx squared is equal to 1 over x squared dy dt plus 1 over x multiplied by d over dt, this part here, multiplied by dy over dt, this part here, this is the dt, then multiplied by dt over dx, this x dt, this one, and this dx here. Then from here now, we note that dt over dx is 1 over x, the one we found here. Dt over dx is 1 over x. So we substitute it in our equation down here, so that we get minus 1 over x squared dy dt plus 1 over x d squared of y over dt squared multiplied by 1 over x. This can be written as negative 1 over x squared dy dt plus 1 over x squared d squared of y dt squared. Then we multiply by x both sides, so that we get x squared d squared of this dx is equal to minus dy dt plus d squared dy of dt squared. Then we note that dy of dt, we found it to be d of y. So in general, to solve a linear ODE with variable coefficient, we make the following substitution: x is equal to exponential t, so that natural logarithm of x is equal to t, and we also substitute d of dt is equal to capital D, x dy of dt is equal to dy, and then we substitute x squared second derivative of y with respect to x to be equal to d into bracket d minus 1. We also substitute x cubic d, then derivative of y with respect to x to be equal to d into bracket d minus 1, d minus 2. So we make those substitution, and then we are able now to solve the second order ODE, which is linear and which has variable coefficient. So thanks so much for taking your time to study with me. For more such learning, kindly tune on to my YouTube channel so that we may continue learning together. Remember also to subscribe to this channel so that you don't miss a single video which I upload for us every day. Bye bye. See you in the next study.